Okay, so now we're ready to dive into sample spaces. Sample spaces are basically, we're going to list all the possible outcomes. I'm also going to use I'm just going to go ahead and introduce another definition for us. We're going to look at tree diagrams to help us build sample spaces. So the first event is flipping two coins. Note that this is not a simple event because we're actually doing two things, right? We have different outcomes. So when you try to think about the different outcomes from flipping a coin, we could get two outcomes, right? We can either have it land on heads or land on tails. So what we can see right here is this is our first coin, right? This is the first flip of the coin, and the results were heads or tails. Now, I'm flipping a coin twice, so what we're going to need is we're going to build a second level here. Underneath each of the previous outcomes, we're going to think about, okay, when I flip the second coin, what are the possible outcomes? Well, each of these, it's basically the same thing. I could get a heads or a tails, or a heads or a tails. Now let's take a look and let's dive into how this helps us understand what the different outcomes are. We read this like these are the branches on a tree. So you can see that the first outcome is I could get, so we're going to go over here and write our sample space, I could get a heads and a heads, right? Now we can follow down this way, I could get a heads or a heads and a tails. Or when we read down over here, this is the outcome, tails, heads. And then finally, the last outcome right here is tails, tails. So we're going to let event A be the probability of getting two heads. I take a look up here, we see how many total outcomes are there in my sample space. There are 4 of them. And then how many of them is the event that I am looking for, which is getting 2 heads? It's this one right here. So the probability of getting 2 heads in a row is 1 out of 4. Now let's talk about the probability of that not occurring. Again, you could probably just go up here and count. There's 1, 2, 3 different ways that that doesn't occur out of 4. Or using the idea of complement that we talked about previously, we can do 1 minus 1/4, which gives us 3 over 4. If you're not a big fan of fractions, just go ahead and go over to your calculator and just do 1 minus 1 over 4. And then, or some people have a fraction button if you're using a TI-30. If you're using a TI-83, we're just going to hit Math, Enter, Enter to turn this back in, and we get 3/4, same thing we had. All right, the next one, having 2 children. So we're going to have a very similar tree diagram set up. So the first tree is we're going to think about what are the possibilities when I have my first kid. It is a boy and a girl. Again, we are assuming that we don't have twins, but we're just talking 2 kids. Okay, you could either have a boy or a girl for your first kid. So this is the first child. Again, you kind of see the levels. This is the first level, and then from each of these, we're going to have a set of branches. So boy, girl, coming from here. And then we're going to read down these, and we can see that our sample space is, we could have a boy and a boy and a girl. We could have a girl and a boy. Or finally, reading down this last outcome is a girl and a girl. Again, you could probably come up with this one yourself. It's just two events, but once we get more events is where the tree is really nice. All right, so the probability of having 1 boy and 1 girl in either order, there are 2 of those out of a total of 4 items in the sample space. Now, we want to reduce this, so we're going to reduce 2 over 4 to 1/2. So the probability that does not occur, it's 1 minus 1/2, which is also 1/2. All right, the next trial is rolling 1 6-sided die, so we're going to think about that. What are the possible outcomes? If I have a tree, it's going to be a simple event, right? Because I can just get a 1, 2, 3, 4, 5, or 6. It's not complicated. There's not multiple trees. There's not going to be multiple levels to this tree. That's it. That's what I can get, right? So when I do a sample space, it's going to be 1, 2, 3, 4, 5, and 6. We're going to define event A as rolling a 5. We can see there is 1 5 in that list of possibilities. Out of how many total possibilities do I have in my sample space? 6. So the probability of rolling a 5 is 1 out of 6. What's the probability that I don't roll a 5? Well, that's 1 minus that, which is 5 out of 6. All right, the last one that we're going to take a look at is rolling 2 die. So rolling 2 die, all right, I'm going to maybe look at this. I start to try to do my sample space, right? Or my tree diagram. And then I think about it, 1, 2, 3, 4, 5, 6, right? For my second roll, I'm going to need to have 6 branches coming off of all of these. This is not a great time to do a tree diagram. You can see right here, this is nasty. I don't want to write all these numbers out. So we're going to work on a different method to be able to write this sample space. And it's really basically just, we got to just think about it systematically, okay? So the best way to do this systematically is, let's start with what I could get first. I could roll a 1, right? And then a 1 again, right? So this is how I identify getting 2 1s in a row when I roll 2 die. Then what could happen next? I could get a 1 and a 2, or I could get a 1 and a 3, 1 and a 4, 1 and a 5, and finally 1 6. All right, and then I move on. The next would be 2 1, 2 2, 2 3, 2 4, 2 5, and 2 6. All right, I'm going to hit pause in the video and finish this list up. Why don't you hit pause as well and try to write them all out? I know this seems very tedious, but it's nice to work on this systematic method of getting all of the sample space written. It helps with something called permutations, which we're going to cover later. So just go ahead and hit pause and try this once for yourself. Okay, so that took me a while. But I got them all written out. You can kind of see how I've represented them. It's kind of nice to see them in a nice grid where you kind of have 6 across. And then if I needed to do my set notation, I would just create my brackets really big and around this whole set. So let's see how many we have. We can take a look. This is a little bit of geometry, but you see I have 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6. 6 by 6. This square, there are a total of 36 different outcomes. You can go through and count them one by one, but that's a nice way to get, if you have a box like that, to find the number of items. All right, so event is rolling a 3 and then a 5. You see that this and then, this looks like order matters, right? So it doesn't say a 3 and a 5 in either order. It needs to be specific. This says 3 and then a 5. So I take a look, and there's just one place in my sample space right here that I see that rolling a 3 and then rolling a 5. So there is one of those out of, we said there's a total of 36 items in our sample space. So the probability of not rolling a 3, well, you can go through and you can count all of those items again. This is a nice time to just do the subtraction, and you get 35 out of 36.